Hello everyone, I am Hina Janbandhu and today I will be explaining the designing and implementation of combinational circuit using Verilog. So the combinational circuit which I am going to use is 3 to 8 decoder. First of all, we will see what is decoder. The combination circuit that changes the binary information into 2 and output lines is known as decoder. The binary information is passed in the form of n input lines. The output lines define the 2 and bit code for the binary information. In simpler words, if we say that it is the decoder performs the reverse operation of the encoder. At a time, only one input line is activated for its simplicity. The produced 2 and bit output code is equivalent to its binary information. Next, we will see what is the purpose of 3 to 8 decoder and what is 3 to 8 decoder. 3 to 8 decoder is also known as binary to octal decoder. In a 3 to 8 decoder, there are total 8 outputs, that is Y0, Y1, Y2 till Y7. And 3 inputs, that is A0, A1 and A2. This circuit has also an enable input E. Just like if you have studied previously about 2 to 4 line decoder, here we are using the enable E, and if it is set to 1, then we will get one of these 4 outputs will be 1. The same way 3 to 8 decoder also works. If enable E is 0, then we will get one of the 8 outputs, that will be 1. So this is the truth table of 3 to 8 decoder. Here you can see when enable E is 0, here A0, A1 and A2. All these are the don't care conditions. We will not get any kind of output. When enable is 1 and the combinations are there of A1, A2, A0 like 0, 0, 0, then we are getting output as Y0. When it is 0, 0, 1, we will be getting Y1. For 0, 1, 0, we are getting Y2. For 0, 1, 1, we are getting Y3. 1, 0, 0, we can see we are getting output as Y4. The same way it goes on, and here the logical expression for all the terms is also mentioned here. This is the block diagram of 3 to 8 decoder. Here you can see inputs are given as A0, A1, A2, and Y0, Y1, Y2, Y3, Y4, Y5, Y6, and Y7 are the outputs. Any one of the output will be 1 based on the enable and the combination of the inputs. This is the logic circuit diagram of 3 to 8 decoder, which is made up of inputs as A0, A1, A2, and so the outputs Y0 till Y7. We are included here the AND gates and NOR gates. Then next we will see what is Verilog. Now Verilog is a hardware description language that is used to model and simulate the behavior of electronic circuits, especially the digital circuits. It allows us to create a virtual model of a circuit, which helps us to test and to see how our circuit behaves before building it in a real life. It makes it easier for us to design and fix the problem in circuit. Then why we should use Verilog? It simplifies the design process and it allows us the testing of circuit before implementing them in hardware. This is the most advantages of using the softwares like Verilog and all, that we are getting uh, means we will be testing a circuit before only, so we will know what errors are there and what we need to fix it in our circuit before implementing them in the hardware. Next is the Verilog code for 3 to 8 decoder. This is the main code and this is the test bench code. Here you can see this is the file name module decoder 3 is to 8. Then input A, which is given in the vector form, that is 2 is to 0. Output 5 also given in the form of vector, that is 7 is to 0. Here always block is added with the sensitivity list. Then case is used. For case A, we are using means A is our input, so cases will be implementing on input. If our input is 0, 0, 0, then we will get here the output as 0, 0, 0, 0, 0, 0, 0, 1, which is Y0, Y1, Y2, Y3, Y4. The same way how we have mentioned in our truth table, the same way the process is followed while writing the code of it. In the cases, for every case, what will be the output, we have to write list all of it. And again, when default is set because if our enable is 0, then there will be no output. And if enable is 1, then we will be getting this outputs. So the default case is also included here in the case statements. Now we will end our cases and the always block, and the end module. Next is our test bench code. Test bench code also is the same, like input is mentioned, output is mentioned, then the decoder name is mentioned, then we are initializing here, and we are giving the delay or wait, we can say, and the test cases are mentioned here, like what will be the output when we are giving the inputs, and we are ending our module. Here you can see this is the Xilinx ISE code for 328 decoder. This is our main code which is used for synthesis and implementation. This is the same as I have explained in the previous one slide. I have copy pasted it from here only. This is the screenshot of it. This is the RTL schematic diagram which you are seeing here. This will the first block which you will see when you will click on the RTL schematic. If you are double clicking it, then next you will get to see like this. And then third image which you will be getting to see is this one. This is like the circuit photo which I have shown you earlier. Like the same way here, AND gates are used based on their inputs, which output you will get. Output means only one output will be one at a time. This is our test bench file. This is the simulation waveform which you will get. So at last we will see what is the application of decoders. Decoders are used in 7-segment display decoder, barcode scanning, security systems, television remote control, address decoding, and sound synthesis. So I would like to conclude this now. So from the previous truth table, simulation, logic diagram, it is clear to all that only one of the 8 outputs from Y0 to Y1 will be selected on the basis of 3 select inputs. So that's all. Thank you so much.